Today, we will learn about the special appearances of minerals in reflected light. These are some of the visible optical properties of minerals that we will learn more in detail about. The emission of visible light by a crystal that has been excited by ultraviolet light is luminescence. This special property is checked macroscopically by placing the mineral under a long wave or short wave UV light. The reaction of a mineral may differ based on the source of the wave. The reaction may be the same or even different. For instance, a mineral may react under one wave but not the other. Also, there may be change in the color emission of the mineral depending on the wavelength used. Luminescence is also known as photoluminescence, that is a stimulation caused by irradiation with UV light and is best observed in darkness. Fluorescence. The emission of light at the same time as the occurrence of irradiation is fluorescence. The release of energy is done in two or more steps, from which one step is in the visible range of spectroscopy. This property is vital to geology, more particular to gemology and mineralogy. Phosphorescence. If the emission of light continues even after irradiation is terminated, then it is termed as phosphorescence. The phenomenon occurring here is such that the excited electron falls into an electron trap and remains there for hours. The system's thermal energy causes the recombination of the excited electron with the positive ion. The light that is observed in phosphorescence is the light emitted during recombination. Iridescence. The reflection of white light from structure of minerals which leads to a varied display of colors is iridescence. A common term for iridescence is play of color, a phenomena that is more than often observed in bubbles. Diffraction, reflection from thin films within the mineral, crystals, liquid-filled intrusions, cleavages, and fractures can cause the phenomena of iridescence. The thin films within the mineral may be existing as solids, gases, or liquids. Iridescence is observed when colors in the white light either experience weakening, elimination, or strengthening. Labradescence. Labradescence does not involve surface reflection, but instead reflection of light that has struck the internal twinning surface. Different colors of light are reflected by different twinning surfaces within the stone. Simultaneous reflection of light from different twinning surfaces of the stone can lead to a multicolored appearance. Aventurescence. The optical reflectance seen in certain gemstones is known as aventurescence. This phenomenon is also known as metallic glitter because of the minute plate-like mineral inclusions. If these inclusions are present in abundance, they can influence the color of the stone. The specialty of this phenomenon is the spangled reflections observed in the mineral. Aventurine and sunstone are the two minerals exhibiting aventurescence. Asterism. Asterism is the phenomenon of gemstones exhibiting a luminous star-like shape when the mineral has a Capricorn cut. However, one should note that these gemstones are polished and shaped rather than faceted. This phenomenon is displayed by some rubies, sapphires, etc. of an enhanced reflective area. Asterism occurs due to the presence of titanium dioxide impurities, also known as rutile. The star effect is caused by dense inclusions of rutile fibers. The rutile's needle-like inclusions reflect light in such a way as they are aligned perpendicular to the rays of the star. Rutiles are almost never completely transparent as they are always present in star gemstones. The star sapphire is one such exemplary gemstone. Adularescence. Adularescence is an optical phenomenon that is produced in gemstones such as moonstone. Adularescence is a very unique phenomenon due to it being the metallic iridescence originating from below the surface stone. This type of iridescence occurs due to light being reflected between the mineral layers. The Schiller effect. Adularescence exists only in the presence of light as it is an optical phenomenon. It is not a mineral property but rather the product of the interaction between light and the internal microstructures of the mineral. The phenomenon of adularescence is commonly referred to as the Schiller effect. Opalescence. The invention of the electron microscope led to the confirmation of opalescence being a form of play of color. The unique phenomenon within opal is because this mineral is made up of small spheres of silica, and interference and diffraction together play a role in opal's play of color. Interference within the opal occurs when part of the light gets reflected from the surface of a silica sphere, while another part gets refracted inside the sphere, being reflected again. Diffraction in opal is the result of light hitting a gap between the spheres and then being split up into its spectral components. Smaller spheres result in green, blue, or purple flashes, and hence, in order to give red flash, the wavelength cannot be increased. Therefore, size of the gaps or voids matter in opalescence. Chatoyancy. The unique phenomenon of a mineral to reflect light in such a way that it appears similar to the light bouncing off a cat's eye is known as chatoyancy. Chatoyancy occurs when the reflection of a band of light takes place from within the series of thin inclusions present within. They may be hollow tubes or needle-like crystals of rutile or hematite. The sharpest and finest line obtained through this phenomena is observed in chrysoberyl, the only mineral to be known as cat's eye. This phenomena is also known for its milk and honey effect. Now that we have gone through the visible optical properties in brief, let us see what alexandrite is about. Alexandrite is a very unique gemstone in terms of its color. It is a color change variety of the mineral chrysoberyl. This has led to it being called an emerald by day and a ruby by night. Alexandrite also exhibits chatoyancy, increasing its value. It has an absorption band of 580 nanometer and hence can shift from red to green and vice versa when viewed under different light sources. These are some of the websites I got the information from. Thank you, and I hope you learned something today.